Welcome back, Pre-Algebra. We are in Lesson 32. We're going to talk about variables and evaluation. So a variable is a letter that we use in order to in place of a number we don't know. We use it in order to have a placeholder for that unknown number. So we've been doing some problems like this, like x plus 5 is equal to 8, and then trying to figure out what x is, right? So x in this case would be 3 because 3 plus 5 is equal to 8. X would be our variable. So a variable, you're going to want to write this down or remember this. A variable is a letter we use to represent a number we don't know. Okay? Or it takes the place of a number. It's just like a placeholder. So let's put that in here too. It's a placeholder. And we use it a lot for factors. Okay? So write that. That's important to understand what that variable is. It's like saying question mark or something plus 5 is equal to 8, and then understanding how to undo the addition and subtract these two to find the missing number. So we've been doing a lot of those types of problems, and you didn't even realize you were using variables. So let's do a couple practice problems so we can practice seeing the variable and understanding how to solve it. We're going to do something called evaluation. Evaluation is where you are given a number problem, like this one is xy plus x, but then it tells you what values it wants you to plug into these. So for every x, I want you to put in the value of 2, and for every y, I want you to put in the value of 4. Now it's important to understand that when we have two variables next to each other, those are factors. This means that they're being multiplied times each other. This does not mean that we would have 24 here. Okay? Some people would look at that and say 24 plus 2. That is not correct. When we have numbers or variables next to each other, it is understood that that is multiplication. So what we actually have here is going to be 2 times 4 plus 2. And using our order of operations, we know we have to do the multiplication first. So 2 times 4 would be 8 plus 2, which would equal 10. All right? So you kind of see how that works. Let's do another one. I'm going to clear the page for us. Let's do 32.2. And this one we have x times m times y minus x times y. And x is going to equal 2, m is equal to 5, and y is equal to 4. So the thing that I tell my students to make it easier to solve these is to use what I call buckets. We're going to use parentheses to create a placeholder for the variable. So what I mean by that is everywhere there is a letter, we're going to put a pair of parentheses so that we can drop the value of that letter in afterwards. So we have x times m times y. And it's also handy because when you have parentheses right next to parentheses, that also means multiplication. So it makes it easier to see that you are multiplying the variables when they're right next to each other. So now we have another pair here, and these are, again, factors. They're being multiplied against each other. So for every x, I'm going to put in the value of 2. So I have an x here, and I have an x here. For m, the value is 5. I only have one of those, and that's here. And for y, the value is 4. So I'm going to put 4 here and 4 here. Now I see exactly what I need to do, and I'm going to go ahead and do it. 2 times 5, that's going to be 10. So that becomes 10 times 4. And 2 times 4 is 8. So I'm going to have 8 right there. So 10 times 4 is 40 minus 8. That is going to equal 32. All right, let's do another one. See, these are not so hard. You just have to get in the habit of understanding the buckets and how to use the buckets. So here we have another one. We have mx plus 4m. All right, and in this one, x is equal to a fraction. It's 2/3. And m is equal to a fraction. It's 9/11. Okay, so we're going to put our buckets in. So we have a bucket for m and a bucket for x plus 4 times m. So my value for m is 9/11. So I have 9/11 here, and I have 9/11 here. And x is 2/3, and it goes here. So now that I have all of my values in the right way, I can do the calculation. So multiplying fractions, we just go across the top and across the bottom. So 9 times 2 is 18 over 11 times 3 is 33. Now when we multiply a whole number times a fraction, we turn the whole number into a fraction by just putting it over 1. All right, I'm going to bring down the operation. 4 times 9 is 36, and 1 times 11 is 11. Well, we can't really do anything with this yet because they don't have the same denominator, right? But I know that I can reduce this fraction, and then I can have 11 as my denominator. So I'm going to divide this, and the way I'm going to divide this, I'm just going to come over here to the side, and I'm going to write out the factors of 18. And the factors of 18 are 3 times 6, okay? And 6 is 3 times 2. So those are my prime factorization of 18. And for 33, it's just this up here. It's 3 times 11. That's all I can do. So I can factor out a 3, which is the same thing as dividing this by 3 and dividing this by 3. So that means I have 3 times 2, which is 6/11. So 6/11 plus 36/11 is equal to 42/11. And 42/11 is the answer that I prefer that you use. I prefer that you use an improper fraction. Okay? Sometimes your parent is going to say, oh, you need to put that in a mixed number. It's not finished. If your mama says that, then do what your mama says. The system will most likely take both. It does a really good job of taking an improper fraction and comparing it to a mixed number, but it can also take a mixed number and compare it to an improper fraction. So if you simplify this for the sake of what your mama said do, I'm not going to argue with your mama over this. Either one would work, okay? But I want you to be thinking about, as we get into higher mathematics, especially once you start hitting Algebra 1 next year, this is going to be the format that algebra prefers. Algebra does not like mixed numbers. It hates mixed numbers because with a fraction like this, I can find the factors of 42. And if I need to, I can factor some things out. I can't do that with a mixed number. I can multiply one fraction times another. You see like this? I can multiply that. I can't do that with a mixed number. With a mixed number, I have to turn it back into an improper fraction in order to do multiplication with another fraction. That's just the way it works. So, I prefer this answer. I'll take this answer grudgingly. But if your mother is making you, or whoever's helping you with your math work, if they say, well, that's an improper fraction, you need to put that in a mixed number, they are right. It is an improper fraction. And if they want you to go through the practice of division in order to do this so that you understand what you actually have, be obedient, okay? And follow their lead. But you can type in either one of these answers into the system. That's what I want you to understand. Okay, as we get into higher math, especially in algebra, this will be the answer that I want you to type in. All right, so let's see. That is all we have for lesson 32. And all you're doing is you are making buckets for each letter and then taking the value that it tells you, putting it into the bucket, and then doing the math in the order that we know we have to do it in based on the order of operations, or PEMDAS, that we learned about in lesson 31. And that's all I have for you today. I'll see you in lesson 33.